Hello, dear students. As we know, we have discussed the different kinds of factorization in the last, you may say, previous video of chapter polynomials. Today, I would like to discuss about the questions on the basis of that factorizations. We have done some questions in that exercise 2.3 and some questions of exercise 2.4. I would like to discuss some more questions of exercise 2.4 from NCERT. See the question number 4 in second part. Question is given in the format of 2x square plus 7x plus 3. I would like to recall the previous one category. Out of that, there was a category if the number of terms are 3, and that is in the form of ax square plus bx plus c. Means question is in the form of trinomial, means number of terms are 3. So here number of terms are 3, and this is similar to the ax square plus bx plus c. So we will use the specific method, that is splitting of middle term, because all the trinomials can be solved by using this method. Okay, so let's solve this one. 2x square plus 7x plus 3. After comparing this to the ax square plus bx plus c, a equals to 2, that is coefficient of x square, and the constant term is 3, means c equals to 3. As I told you in that, you have to find the product of a into c. Here a is 2, c is 3, so 2 3 is 6. Now see the sign of constant term. Sign of the constant term is positive. So find the factors of 6 in such a way product is equals to 6, and their sum should be equal to coefficient of middle term, and coefficient of the middle term b, that is given as 7. So factor of the 6 is 6 into 1, 6 1 is 6, and 6 plus 1 is 7. So in this way we can split the middle term. So replace this 7 by 6 plus 1. See 2x square, open this bracket, 6x plus 6 plus 3. Now making the group of first two terms and last two terms, this will be 2x as the common. Now remaining terms are x, and it is 3, right? And again common between last two terms, common between x and plus 3, that is 1. So it is again taking common as x plus 3. Now remaining term 2x, this one and this one is plus 1. So these are the two factors, x plus 3 and 2x plus 1 of this trinomial. And this is the process to factorize and to find the factors by splitting middle term. We will try to understand this factorization with the one more question of the same exercise, and I took the question number 4, fourth part. I would like to repeat the same. Yes, some differences are there, that's why I took this question. In this question 3x square minus x minus 4, a equals to 3, c equals to 4. As I told, we have to find a into c. This is 3 into 4, it is 12. Just see, coefficient of x is 1, that is b, and the sign of the constant term is minus. So you have to find the factors of 12 such that their product is equals to 12 and difference should be equal to the 1, that is b, right? So 4 3 is 12, and 4 minus 3 1. It is we are trying to fulfill all the conditions which is required to solve such questions, correct? So instead of 1 we will write down 4 minus 3. So let's proceed for this. In the second step, you will write 3x square. Instead of 1, write down 4 minus 3 into x minus 4. Now open this bracket. This will be 3x square minus 4x plus 3x minus 4. Again making the group of first two terms and last two terms. Common between these two, x. Remaining terms are 3x minus 4. Again common between last two terms, that is 1, and this is 3x minus 4. Again taking the common as 3x minus 4, this, and remaining terms are x, and this is plus 1. So in this way you can solve the different questions of trinomials, and method will be splitting of middle term. Splitting means you have to break down the middle term in such a way total number of terms are being 4, and then we can make the group of first two and last two. Okay, let's proceed for the next step, that is question number 5th. We will select one question and we will try to understand this thing. Again I would like to repeat that thing. We have done I think 4 or 5 questions as an example to understand about the factorization on the basis of factor theorem. So given function or the given polynomial is x cube plus 13x square plus 32x plus 20. In this polynomial constant term is 20. So first step to solve such question, find out the constant term and then find the factors of that constant term. As we know, factors of 20 is 1, 2, 4, 5, 10 and 20. Factors means the terms which can divide the 20 exactly, right? So we have a possibility, means we can put x equals to plus minus 1, either plus minus 2, plus minus 4, plus minus 5, plus minus 10 or plus minus 20. By using hit and trial method, you can put any one value. So I think you should start from the beginning. Since in the given polynomial all the terms are positive, so we will not take the positive value of x, right? Because these are the decisions which will be taken by you. That's why I am taking x equals to minus 1, right? We will put this value in the given polynomial. If remainder will come as a 0, we will confirm yes, this is the zeros, and then we will find out the factor. So let's put this value in the given polynomial f minus 1. Minus 1 means instead of x we are replacing as, so f minus 1, this is minus 1 cube, 13 into minus 1 whole square, 32 into minus 1 and plus 20. Minus 1 cube is minus 1, square of minus 1 is plus 1, and plus 32 minus 1, plus into minus minus, and 32 into 1 32, and this is 20. Now minus 1, this is minus 1, plus 13, minus 32 and plus 20. Minus 32 and minus 1 are the like term. So minus 1 and minus 32, minus 33, and this is 13 1 ja plus 13 plus 20. Overall it is minus 33 plus 33, and these two terms will be cancelled because both are equal in magnitude and they are opposite in sign. So result is 0. At the end we are getting f minus 1 equals to 0, means remainder is coming as 0. So we can write x equals to minus 1, and this implies to x plus 1 equals to 0, as we have computed the zeros, right? Therefore as a conclusion we can say x plus 1 is a factor of fx, right? That day one more thing I told you, there are two methods. Either you may use the long division method or you may use the horizontal division method. So today we will again try to learn the horizontal division method. Since the given polynomial is of 3 degree, so we will write down x plus 1 3 times. So first time this is x plus 1, x plus 1 and x plus 1, and as you can observe there are some space in between these factors, right? Now multiply this x with a term in such a way you will get the x cube, because the first term of the polynomial is x cube. Therefore we will multiply this x square to x, and in this way this will be x cube. Multiply this x square to 1, then this is plus x square. Again check the question. In the given question second term is 13x square and we have x square. So in the next step we must have 12x square to make that as the 13x square. So to get this thing we should multiply the next term by 12x. So 12x into x, 12x square, and this 12x into 1, this will be 12x. And in the question third term is 32x and we have this 12x, so next term should be 20x. Therefore we will multiply the next term by plus 20. Whenever we will multiply this plus 20 to x, this will be 20x, and this 12x plus 20x, it is overall 32, and 20 into 1, this is plus 20. This is overall actually rough work, and this is the way to expand the given polynomial, right? Now this entire polynomial is in this form: x square, x plus 1 plus 12x, x plus 1 plus 20, x plus 1, where x plus 1 is the common and the remaining terms are x square plus 12x plus 20, correct? Now this portion x square plus 12x plus 20, it is in the form of ax square plus bx plus c, means it is in the form of trinomial. And as we have done the questions of trinomial by splitting middle term, we will proceed with the same. So let us find out a into c. So a means coefficient of x square, that is 1, and c is 20. So 1 into 20, 20, and then find the factors of 20 such that product is 20 and their sum equals to 12. So that will be 10 2 ja 10 2 ja 20, and 10 plus 2 12. So instead of 12x we can write 10x plus 2x, again taking common between these two. X is the common, x plus 10. In between these two last two terms common is 2, x plus 10. This is x plus 10 and remaining terms are x plus 2. Finally you can write this in the proper manner: x plus 1 into x plus 2 into x plus 10. These are the three factors of given polynomial, and here we have used the factor theorem. In this way you can solve the remaining questions of NCERT, right? 4 questions are given. Out of that 4 we have solved 1, right? And this is the maths IP, and I hope you will be able to solve remaining questions, correct? The next segment of this chapter is factorization based on the algebraic identities, right? Some algebraic identities are given in this book. I would like to repeat that once again because some of them are given in the junior wing also. So first one identity is x plus y whole square equals to x square plus 2xy plus y square. This is x minus y whole square equals to x square minus 2xy plus y square. Third is x square minus y square equals to x plus y, x minus y, and this is also known as difference formula. X plus a into x plus b equals to x square plus bracket a plus b into x plus ab. Next is x plus y plus z whole square equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Next is x plus y whole cube, that is x cube plus y cube plus 3xy bracket x plus y. Next x minus y whole cube, x cube minus y cube minus 3xy x minus y. And the eighth one is x cube plus y cube plus z cube minus 3xyz, that is equals to, in the first bracket x plus y plus z, and the second bracket there should be x square plus y square plus z square minus xy minus yz minus zx. So these are the important identities which will be able to solve, that will be helpful to solve the questions of exercise 2.5. Correct? So many questions are given in this book and so many questions are given in the other book. So we will try to understand one of them. How to use these identities. I will solve the questions one by one using these identities. So I took the one question as question number 1, first part. It is given in the form of x plus 4 into x plus 10, right? If you will see this question, then you will observe one thing: x plus 4 and x plus 10, if you are taking 4 as the a and 10 as the b, then this is in the form of this identity x plus a into x plus b equals to x square plus a plus b into x plus ab. So using this identity we can solve this question without real multiplication method, using distribution method. We are not going to use the distribution method, we will use these identities, right? So taking x plus 4 into x plus 10, as per this formula there should be x square, first term as it is, there is no difference, plus a plus b, so instead of a it is 4, instead of b it is 10, so 4 plus 10, and here as the formula there should be x plus a into b, that is 4 into 10. Now this is x square, 4 plus 10, it is 14x, and 4 10s are 40. So this is the solution of this question, and here we have used identity, right? In the same manner we can use the identity. 8 identities are there, and definitely we will solve the question on the basis of each and every identity. I would like to explain one more question of the same question number 1, that is fourth part. In this fourth part, question is given as y square plus 3 upon 2 and y square minus 3 upon 2. We can observe, okay, this is first term plus second term, and in the second bracket first term minus second term, means we can consider y square as a and 3 upon 2 as b. Then this is in the form of this identity a plus b into a minus b, and that is always equal to a square minus b square. So taking this question as y square plus 3 upon 2, y square minus 3 upon 2, and just consider a as y square and b as 3 upon 2. Therefore their right side should be a square minus b square, so we can write it as y square whole square as it is a square, and minus 3 upon 2 whole square as it is b square. After squaring y square, this will be y power 4, as we know the indices rule, and square of 3 is 9 and square of 2 is 4. These are the two parts, and definitely I will prepare one more video, and in that video I will try to discuss the questions related to the remaining algebraic identities. Okay, thank you very much. Do the questions of exercise 2.5 and I will send you as the IP. Thank you very much.